Sounds like our basketball team did good yesterday. We'll go to Gabe. You're right.
Yeah.
All right. Did we forget their school tomorrow?
Yeah.
Their school tomorrow.
Thank you for calling.
Now that you officially know, no reason to miss. Okay, here we go. I'm going to start off with the steps. We're going to list all the steps out. And then, just like with anything, even though we list the steps out, this might not pertain to every problem. But as long as we have the steps down and we start at step one, we're like, do this. Well, we don't have to. Then we move to the next step, and then we move to the next step. We're going to start off with as simple as we can get, 2/3 plus 1/5. Just show you how it works with just numbers, and then we'll just keep adding on to it and make it a little bit tougher. Okay? So, this is section 8-5, adding, subtracting fractions. Okay? Let me list, I'm going to put the steps right here so we can refer to it as we're going. All right, here we go. Number one, what you need to do is add parentheses around, I forgot to remind you, we're going to take a quiz tomorrow off of multiplying and dividing fractions, like what we did the other day. Okay, and I put a couple on your worksheet today to help you review it a little bit. But no adding, subtracting on the quiz. It's just going to be like you did yesterday and the day before, just multiplying and dividing that. And we can do one together once I give you your worksheet. Okay, so add parentheses around any binomial / trinomial in the denominator. We don't care about what's in the numerator, okay? So for instance, if I asked you to add 2x over 4x plus 4y plus 2y over x plus y, I would put the denominator in parentheses. I don't care about the numerators. I only care about the denominators, okay? So we won't put them in the numerator, all right? Step 2, you are going to factor the denominators if you can. Maybe you can. Like right here, could I factor 4x plus 4y? What could I do to that? I could take out a 4, and I'm left with x plus y. Can I take out anything there? No, so I would just leave that as x plus y. So I would factor the denominators if I can, okay? Here is the worst part, the next 2 steps. You are now going to find your LCD, which is your lowest common denominator. And that's where some people have troubles, your lowest common denominator. Okay, yep. I get it when I say what's the lowest common denominator of 3 and 6, it's 6. But what's the lowest common denominator of 4x squared y and 12x y to the third? That becomes a little bit tougher. Okay, we'll talk about it as it comes. Okay, and here is the worst part. Now you have to make equivalent fractions.
Oh. Like all the...
Your denominators must be the same. You can't add fractions unless you have the same denominator. Right now, I can't add these together. I have to make equivalent fractions. Okay? Next step. You are then going to add or subtract the numerators. You are going to simplify the numerator. And then guess what you're going to do again? Now you have to simplify, which means that you might have to factor again and cancel. Now, is every one of these steps always being done? Absolutely not. But sometimes you're going to have to do all of these steps, okay? And those kind of problems get a little dicey. All right, we're going to start off with as basic as we could get, and we're just going to keep adding on to it, and you can see how the progression works, okay? Again, you've got to show your work on these. I can't think of anybody can add these up in their head and like, well, that looks like it's going to be 4x plus 6y plus 2 all over. How the heck are you getting that? Okay, you've got to show your work. It's the only way that you can figure things out. Okay, here we go. Let's start off with as easy as we can get. And I put these on your worksheet. Now, I know that in the past, I showed you how to add fractions in your head. Anybody know what that answer is real quick? What is it?
10 over 3.
10 over 3.
Butterfly.
Close.
11 over 3.
Close. No.
13.
13 over.
15.
It's 13 fifteenths.
How do you get
Our answer is 13 fifteenths. Now, do you think we can use this method on this problem? No. Okay, that's the bad thing. How did I get it? I went 2 times 5, which is 10, 1 times 3, which is 3, all over 15. 13 fifteenths. Okay? So I can add those up that way, right? But let's do it the traditional way, because we're going to have to do most of our problems the traditional way. Here we go. I have 2/3, what was it, 1/5?
Yeah.
Okay. Let's just follow our steps. Step 1, is there anything that I need to add parentheses around? No. Step 2, find or factor the denominator. Well, there's no parentheses. I don't have to factor. Step 3, find the lowest common denominator. What does 3 and 5 both go into?
15.
So I would go 15, 15. I have to make equivalent fractions. Now here's how you make equivalent fractions. And I know it's like, wow, this is a lot of work. I'm doing it the long way so that we can do that problem here in a minute, okay? To find equivalent fractions, remember what you do. You take your new denominator divided by your old. I'm going to take 15 divided by 3, which is 5. I just take this divided by that, right? And now I take 5 times 2. I take this answer times the numerator. Isn't 10 fifteenths the same as 2/3? If I asked you to reduce 10 fifteenths, it's 2/3. They're equivalent. Well, whatever you do to one side, you have to do it to the other. I'm going to take 15 divided by 5 now, which is 3. Now I take 1 times 3. I've made equivalent fractions. 3 fifteenths is the same as 1/5. This is the traditional way to add fractions. You found common denominators and you made equivalent fractions. Okay? Now that your fractions are the same, I can add them together. 10 plus 3 is 13. Okay? I see a lot of puzzle books like this is something you've never seen. This is adding fractions. This is the traditional way to do it. Okay? Let's just quickly do one more just to make sure that we're good before we move on. 7/8 plus 2/4. What is my lowest common denominator? What does 8 and 4 both go into?
12.
They don't go into 8. Or 8 doesn't go into 12.
16.
They both go into 16. Is that the lowest common denominator? 8. They both go into 8. Would it be wrong if you said 16? No, but that just means you have to reduce in the end. So I'm going to put 8. My lowest common denominator is 8. Now, I know when I take 8 divided by 8, I get 1. Right? 8 divided by 8 is 1. 1 times 7 is 7. That makes sense that that doesn't change because that's my lowest common denominator. But over here, I'll take 8 divided by 4, which is 2, and now I take 2 times 2. Isn't 4/8 the same as 2/4, which is the same as 1/2? They're the same thing. Okay, now I can add them together. 7 plus 4 is 11/8. Leave your answers in proper but reduced. Okay, do you see how this works? We're going to do the exact same thing with variables. We do nothing different. It's just that it's a little bit more algebra work now. Okay, we good so far? All right, here we go. I'm going to need to erase this. So now Let's throw some variables at you. 4 over x plus 1 over 2. Like I said, we're going to start off pretty easy. Let's spend a minute talking about LCDs, how to find lowest common denominators with variables. I'm going to come back to this in a minute. I'm going to jump off to the side and let's show you how to find LCDs with variables. Okay? If I gave you 4x and a 3x, here, work with your numbers like you would always do. What does 4 and 3 both, what's the LCD of 4 and 3? 12. Okay, so they both go into 12. Now see how they both have an x. You have to have at least one of every variable. At least one of every variable. So my LCD here would just be 12x. Not 12x squared, it's just 12x. Okay? Just to show you how this problem could change, if I change this problem to this, what do you think your LCD would be now? 12. You need an x, and what else do you need? A y. This would be 12xy. You need one of everything. Just keep that in mind. You need one of everything. How about if I went 4x squared y, 3xy? What do you think your LCD would be now? 12. 12 what? X squared y. Notice that this has 2 of them and this only has 1. So when you're doing LCD with variables, you always pick the highest exponent. If this has 2, then this has to have 2. So it's going to be x squared y. Okay? What if this was, I'm going to cheat a little bit, what if that was your problem? 4x squared y, 3x y to the third. What would be my LCD now? Y to the third, right? I got to have the highest exponent. If there's 3 over here, I have to make it 3 over here. Highest exponent, okay? Mixing it up a little bit. What do you think your LCD would be of, if you've already factored and you had something like this? What do you think your LCD is now? Work with just the numbers. What does 4 and 2 both go into? 4. Is there a smaller one than 8? 4. Now you have to have one of everything. So I'm going to need a x plus y, and I'm going to need a x minus y. You got to have one of everything. And those parentheses are considered one thing. Okay? That makes sense on how LCDs work? Okay, now we'll start applying it to this problem, and we'll do a couple of quick ones and we're kind of done hopefully. All right, let's look at this problem here. Can I add parentheses anywhere? Do I need to factor anything? What is my LCD? I need a 2 and I need a x. So my LCD is 2x and 2x. Got to have one of everything, right? Now we're going to make equivalent fractions. This is where showing your work is really important. I'm going to take 2x divided by x. And what's left when I take 2x divided by x? 2. So that means I just have to take 2 times 4. Right? Whatever's left, I multiply by the numerator. 2 times 4 is 8. Now, just to show you that this is true, if I gave you 8 over 2x and I told you to reduce it, doesn't it reduce to 4 over x? It's the same problem. I just made it equivalent. Okay? Now I come over here, do the exact same thing. 2x divided by 2 is x. So now I have to multiply 1 times x, which is 1x. Okay. Simplify the top. Now notice where we say now. Add and subtract the numerator. I have a common denominator. Can you add 8 plus 1x together? I can't add them, so I just rewrite it. 8 plus 1x over 2x. Now notice it says simplify, factor the numerator. This is a binomial, so I got to put parentheses around it. Is there anything I can do there? Can I take out a GCF? Can I factor anything? then this is my final answer. 8 plus 1x all over 2x. I know a lot of people want to cancel these x's out, but you can't. This is in parentheses. It's got to be identical to cancel. Let's just say this happened, just to kind of give you a different look without rewriting the whole problem. Let's say this is your final answer. Is there anything that I could take out of that numerator?
2.
I could take out a 2, right? I could take a 2 out, and I'm left with 4 plus 3x all over 2x. Is there anything I could cancel now?
2.
I could cancel those 2's out because they're not in parentheses. Okay? See how that works? Does this happen an awful lot? Not an awful lot. Like today, I don't know if it'll happen at all, but I'm just kind of letting you see it. All right. I think we can do one more and hopefully be done, and we can do a problem together to get you going.
Maybe subtract.
Okay.
We don't have any.
Let's do, here's a good subtraction one. We just might as well jump just to the hard stuff right away. Oh, these subtractions are definitely tough ones for people. Let's add these together. This is a good one to go through our full progression. Step 1, do I need to add parentheses in the denominator? Yes. There's a binomial, there's a binomial. Step 2, can I factor any one of those? No. Nothing's factorable. I can't take out a GCF, nothing to do. So what is your lowest common denominator now? You got to have one of everything. You're going to have
P plus 6.
P plus 6, 2P plus 1. I got to have one of every. I'm going to show you what I do with these problems, just so I don't have to write quite as much, and maybe this will make it a little easier for you. When I start to work with binomials, when I do my problems, I just make one single fraction bar, and I write P plus 6 over 2P minus 2P plus 1, just so I don't have to write it out twice. But I still do everything exactly the same. I'm now going to take this and divide by that. I'm going to take P plus 6, 2P plus 1, and divide by P plus 6. Well, what's going to cancel? And what am I left with?
2P plus 1.
I got to take 6 times 2P plus 1. And notice how I write it. Let's do that. What is 6 times 2P plus 1? What's 6 times 2?
12.
12P
Plus 6.
plus 6. Now we do the same thing on the other side. I'm going to take this divided by that. P plus 6, 2P plus 1, divided by 2P plus 1. What am I left with?
P plus 6.
P plus 6. Those cancel, correct? Oh man, I chose a bad example, but we're going to do it. Okay, this would be like tomorrow stuff. Notice you have a binomial times a binomial. What are we going to have to do? You're going to have to FOIL this sucker out. You're going to have to take this times that. You're going to have to FOIL it. It's 2 binomials. Now look at this minus here. I'm just going to write it here for now, and I'm going to FOIL this quickly out. P times P, P times 6,
6P.
negative 3 times P, and negative 3 times positive 6. What do you think I'm going to have to do with this negative now? What's that minus going to do? I got to distribute this negative. This negative affects everything behind it. This negative is now going to become a plus. This is going to become a negative. This is going to become a negative. That's going to become a plus, and that's going to become a plus. I have to distribute that negative all the way through. Now notice our last step. Add, subtract the numerator. Clean up everything. Here we go. I have a negative P squared and no other ones, so I'll rewrite that. I'm going to cross it off. Now I have 12P minus 6P, which is 6P, and 6P plus 3P is 9P, not B, P. Cross those off. And what's 6 plus 18? 24. Rewrite the numerator. Or excuse me, rewrite the denominator. Here's our last step. Is that factorable? what times what is 24 that I can add or subtract to get to 9? What times what is 24 that adds up to 9 or subtracts to 9? Well, I got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. None of those equal 9, right? That's our final answer. There's just nothing I can do. It looks like I can factor it, but there's nothing I can do. There is nothing times 24 that will add or subtract to 9. This is our final answer. Now let's say it does factor. You would have factored it. You're not going to see one like this. I actually chose a bad one. Your ones today are very much, this is what we get to tomorrow though. I'll do probably the hardest one for you guys today so you can just see what we're doing. See the process, see how I show work, and see how I list my work, because it does get a little bit big at times, okay? Today I don't think so much, okay? All right, I lost my lid, here we go. So, let me give you this. It's actually, I wish I wouldn't have done that one, because I don't want you to think, well, these are too hard, I can't. The ones that we do are a lot simpler for today, okay? I'll just quickly, we'll bounce to one of the toughest ones right away, just so you can see they don't look like that. Okay, so first section here, you are just adding numbers and subtracting numbers together, okay? And I don't have a problem doing one of these. If you want to do this by the shortcut method, like we've always done, you can do that. But I think you should start practicing the process to be able to do the harder ones. So I'm going to do this, finding a common denominator. What does 3 and 2 both go into? Now again, I usually just write one fraction like that. I just say 6. Now I'm going to take 6 divided by 3, which is 2, and now I take 2 times 2, 4. 4/6 is the same as 2/3. Now I come over here and I do the exact same thing. 6 divided by 2 is 3. 1 times 3 is 3. So see how I have it over one single fraction when I do it this way? Maybe a little bit easier. What's 4 minus 3? There we go. Look if I would have done it my shortcut way. What's 4 minus 3? 1 all over 6. Okay? But we're trying to think about other stuff, okay? 1 through 6, that's all you do. Now look at 7, 8, 9, 10, 11, and 12. Look at those denominators. What do you notice? They're all the same. You don't have to find common denominators or anything. So we'll just do one of those. Let's do one like 8 with a minus. This Aiden's kind of asking about it, and this would be a better representation than the one I just did. Okay. Here we go. So here's number 8. Right off the bat, you should notice you have common denominators. This problem is ready to go. Okay? Since I already have a common denominator, that's nice. I don't have to do any work other than rewrite it. Now I have to simplify the top, but look at this negative right here. What's that negative going to do behind it? You got to distribute it. And here's what I typically do. I'll just say, okay, this becomes a plus, that becomes a negative, that becomes a plus. I just distribute the negative so I don't forget. Now we're ready to go. What's a plus negative 2a? What's a plus negative 2a? Negative, nope. There's a 1 there. What's 1 minus 2? Negative a. 1 minus 2 is negative 1. So it's negative 1a. Okay? What's negative b plus b? 0. They're gone. Here's our final answer. Negative a over 24b squared. Can I simplify anything? Am I done? I'm done. There's nothing to do. There's my final answer. So here, there's a plus sign. So it's 1 plus negative 2, which is negative 1a. Your b's cancel out, so I don't have to list those. I know this isn't your final answer, but what if this was your final answer? Out of the blue. Could I cancel anything there? I could cancel the b's, because that's a b and that's a b squared. I could do like that, okay? Good? So notice on a 7 through 12, all of those have a common denominator. It's ready to go. Okay, flip it over. Okay. Starting on 13, you don't have common denominators, and you have variables. There's a couple. 18 is what I just did on the board with you. So you could throw out 18. We just did it. So throw out 18. I was hoping not to get into the complex stuff. So let's throw out 18 and let's throw out 21 and 20, or excuse me, look at 21 through 24. That's what you guys did the other day. Do you notice that those are multiplication?
Oh.
So when you get to 21, that's what your quiz is tomorrow. It's just multiplying and dividing fractions. Factor, 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 factor everything and start crossing things off. Do not forget on 21 with the divide sign, you have to flip it. You have to flip that second fraction. It's got a divide sign in it. Okay? All right, but don't worry about 18. We just did that one on the board. So let me do, what would be a good one? 19 or 20? Let's finish up with that. 20, because it has a minus sign maybe. All right, here we go. This will be my last problem to do with you guys. All right, here we go. First step, should I add, is there anything to add parentheses? Yes, the m minus 5. I don't care about the numerators. I don't care about the numerators. Step 2, can I factor that now? Okay, what is your lowest common denominator? You need one of everything.
5.
You need a 5, and you need an m minus 5. That is your common denominator. Okay, I know that there's a 5 in here, but this is in parentheses. It's its own little thing. All right, here we go. We're going to work now. I'm going to take 5, m minus 5 divided by 5. My 5s cancel. What's left? So I immediately write that right there, m minus 5. I actually do all the work so I don't forget. I got to take 3 times all of that. So it's going to be 3m minus 15. I just do the work right then and there so I don't forget about it. Now we come over here and we do the exact same thing. I take 5, m minus 5, divided by m minus 5. What's left? My 5. I just have a 5, right? But I do notice a negative here. Would it be wrong for me to put a plus here and then just put a negative 5 right there and like distribute that negative to the 5? So now when I distribute it, I'm distributing a negative 5, not a positive 5. I gotta watch that negative. Here we go. Negative 5 times 3 is negative 15m. Negative 5 times negative 6 is a plus 30. There's the numerator all done. So I canceled these out. I got a positive 5, but this was negative, so I just distributed the negative right to the 5 and made it a negative 5. Okay? Clean up the top now. 3 minus 15 is negative 12. Negative 15 plus 30 is positive 15. Okay? Look at the top. Can I simplify the top? Can I factor that? Is there anything I can do? Are you sure?
Take out 3.
I can take out a 3. That's a binomial, and so I can take out a greatest common factor. And you know what? Since this is a negative 12, I'm going to take out a negative 3. Let's see what I'm left with. I'm left with 4m minus 5. Okay, I'm going to take out a negative. Is it common to leave a negative in the front like that? No, so that's why I took it out as a negative. Is there anything I can cancel now? Is there anything that is identical top to bottom? Nope, there's your final answer. Okay, so you kind of see why these get a little complicated. And these aren't bad. Wait till you see when they get complicated. These are just kind of starting you off. Yes, Jocelyn?
For the second half of the numerator, I'm like,
This one?
yeah.
This
I
one.
get like the negative 5.
Because maybe, let me show you this. Here was our problem, right? Then these canceled out, I'm left with 5. Well, I know that I got to take 5 times all of that. But since I saw that this was a negative and I knew I had to distribute it, I thought it was easier for me to make this a plus and just put the negative on the 5. And now I just distribute the negative 5 through. Now what some people might do, but there's nothing wrong with this, some people may have done this and said, I see a negative, I'm gonna make this a positive, which makes that a negative, which makes that a positive, and now times it by positive 5, you would have got the exact same answer. So if it makes a little bit more sense to distribute it first, and then just take whatever you get here times that, you're gonna get the same answer either way, okay? It's those negatives. Those negatives are a little tricky. You really gotta pay attention to those, okay? All right, so 1 through 6, you should breeze through pretty quick, just numbers, right? 7 through 12, they already have common denominators. You just gotta add the numerator and then focus on step 6. Can you factor the numerator? Can you cancel anything top to bottom at the very end? Okay? Starting on 13 through 20, which we've already done 20, you don't have to worry about 18. Now you're finding your common denominators and going to work. Okay? Your quiz tomorrow covers 21 through 24. Don't get mixed up. You're not finding common denominators. You're not doing any of that kind of stuff on 21 through 24. You're factoring, 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 factoring. You're factoring everything and then crossing things off. Okay? Good. So we got 15 minutes, all right? And hopefully you can get the first page done. Maybe start a couple on the common denominators on the back so I can come around and help you. Andrew, this came for you.
I'm like totally lost on number 20.
Well, your common denominator's that, right? So when you take this divided by 5, you're left with m minus 5, right? So I gotta take 3 times m minus 5. So whatever's left here, you gotta multiply that by the numerator. So that is how I get 3m minus 15 in the top. That's how I got that. Okay? Now I'm going to do the same on the bottom. I'm going to take 5m minus 5 divided by m minus 5. This one. Well, those cancel out. So you're left with 5. So you're going to have to take this times 5. Okay? So, but notice there's a negative there. So this negative, either you can distribute it right off the bat and make that a negative and make that a positive, and then times everything by 5, you can do it that way. That makes it a little bit easier. So that's how I got negative 15m plus 30. Okay? And then I just add the tops together. Okay? But first, top part should go fast. That's just numbers, not even fractions or variables.
Oh wait, no,
Stop it.
I got 2 after my